All right, so today we're going to talk about graphing, okay, with transformations. So we're going to talk about the variables a, b, h, and k. We're actually going to hold off on b for today, okay, and just talk about a, h, and k. Okay, the three that we have been studying all year long when we've transformed any of our functions. All right, so here is the sine and cosine functions written out, okay, with all the transformations. So you see here it's y equals a times sine of b times x minus h plus k. Okay, and you can substitute sine and cosine, tangent, any of them. All right, and so a is going to be our amplitude. All right, so how high, the distance between the midline and the maximum, or the midline and the minimum, the absolute value, okay, of that distance is the amplitude, and that's going to be given by a. H is going to be our horizontal shift, so you take your parent function, and we could shift that left or right, okay, with our h. Okay, another way they phrase that now is phase shift. Okay, so our phase shift, okay, right there, okay, could show up instead of the word horizontal shift. So that's, but all it is just shifting the graph left or right. Then our vertical shift, okay, is our k. Remember, that's outside the parenthesis, so it's after the sine function, so that's going to move it up and down. What that's really going to control is the midline, okay, so that's an important value there. All right, and the b, which we're not going to get to in today's lesson, has to deal with the period. All right, the period is 2 pi divided by b for sine and cosine. All right, and the 2 pi is because that's the period when b is 1. Okay, the period is 2 pi. It does the full circle before it starts to repeat, okay, is all the way around the circle at 2 pi. All right, so the base period of the parent function is 2 pi, and then we could speed that up, okay, by making b bigger than 1, or we could slow it down by making b less than 1. All right, so what we're looking at here, okay, is the parent function of the sine function, okay, the parent sine function. So sine of x, right? When you plug in 0, sine of 0 is 0. Plug in pi halves, sine of pi halves is 1, right? So this is our graph. Sine of pi, okay, is 0. So first thing, again, I just want to remind you, we talked about this, okay, in the previous lesson, is that notice how the x-axis is numbered in radians. All right, if it's not numbered in radians, it can be numbered in degrees too. So you gotta label your x-axis here, radians or degrees. All right, if it's not labeled degrees, okay, we're gonna assume that it's radians. And the other thing is they don't have to use pi. They could write 1, 2, 3. You know that pi is approximately 3.14. So where it hit the x-intercept would be 3.14 if we numbered it differently. But it makes things nice and easy, okay, when you count by pi halves here. All right, and again, for a parent function, okay, the period is 2 pi. So it starts to repeat after 2 pi. It starts at 0 degrees, goes around the circle, okay, and then it starts to repeat after it gets to 2 pi. The cycle here is from 0 to 2 pi for that period. Again, the cycle could be from pi halves to 5 pi halves. Okay, it's just the distance. Okay, you can start and finish anywhere, but it's going to cover the distance of a period. All right, and so we choose to do pi halves, pi, 3 pi halves, and 2 pi for sine and cosine functions, okay, because we want it to capture the whole thing, and the max, the x-intercepts, okay, the mins, okay, it's not always the x-intercept or the vertical shift, but the max and min and the point through the midline, okay, are going to happen at pi halves, pi, 3 pi halves, and 2 of that quarters, okay, there's 1, 2, 3, you cut that into quarters, okay, and that's where everything's going to happen. All right, so we're looking at any cycle, you're looking at 5 key points, key characteristics. In this case, right, there's three x-intercepts, okay, or 3 points to the midline, 1 max and 1 min. If I just shifted the cycle over, start at pi halves, and then I'm going to have 2 maxes, 1 min, and 2 through the midline. Still 5. 1, 2, 3, 4, 5. So through any cycle, there's 5 key characteristic points. All right, and so we like to number the number line, okay, based on that fact. We want to capture all of those key features on how we count our number line. All right, okay, so now this purpose of this slide is to talk amplitude. Let's see how A, the amplitude, affects the graph, okay, of the parent sine function. Okay, so if we move A, we make A bigger. Okay, you can see now the red dashed line is still the parent function, so it's still there. So now A is 2. Okay, look at that max point. It's at 2. Let's make A 3. Okay, now that max is at 3. And notice the min is at negative 3. The amplitude, the distance from the midline, okay, which the midline in this case is the x-axis, right? The distance is 3 because my A is 3. Okay, even down here, remember distance is not negative, it's the absolute value, right? So that distance is still 3. All right, now if I make my A negative, all right, so let's bring it back to the parent function, okay, right here. At pi halves, there's a max. Okay, watch what happens at pi halves when I make it negative. That max now becomes a min. As we've studied all year, when A is negative, it is a reflection. So naturally, a maximum would reflect down to be, okay, a minimum. And it's going to reflect it over K. Right, whatever K is, that's what it's going to reflect over. In this case, K is 0. All right. So with that knowledge, okay, how does A in this equation affect the graph? All right, and so just looking for a very basic, okay, A is the amplitude. It's right in the title of the page. Okay, A is the amplitude. Okay, the larger the A, the higher or the further the max is from the midline, in which the technical word is sinusoidal line axis, okay, from the midline. Okay, if A is negative, it reflects the graph. So maxes become mins. Right. Okay, now right away I want to sketch the graph, okay, of 3 sine x. All right, so there's a table of values here to help us notice how the x-axis is numbered. Okay, so it's numbered from negative 2 pi to 2 pi. All right, and again, 2 pi is critical. It's the period that we talked about in our previous lesson. Okay, it's going to complete that cycle, okay, over a distance of 2 pi. So if we start at 0, it'll finish that cycle at 2 pi. I should be able to see 2 full periods in here. All right, so let's go ahead and plug in our points right here and see what we get. All right, so when we plug in 0, sine of 0, so you'd go to the unit circle. Sine of 0 is 0. 0 times 3 is 0. So you'll type in 0 here. Okay, so you're going to put a dot right there at 0, 0. Pi halves, sine of pi halves is 1. 1 times 3 is 3. So pi halves, I'm up here at 3. Sine of pi is 0. Okay, 0 times 3 is 0. So pi will be 0. 3 pi halves, sine of 3 pi halves is negative 1. Again, I'm just using the unit circle to find that. All right, and then 3 times negative 1 is negative 3. So that's down here. And then sine of 2 pi is the same as sine of 0. That's 0. 0 times 3 is 0. Okay, now I could come over here and do the same, make my table for these negatives, but we know this is periodic. So it's going to be down here at pi halves is going to be -3, 0, +3, and back at 0. Okay, so my graph, if I could just try to do my best to connect these with my mouse, should be this periodic function with an amplitude of 3. All right. All right, so now we have the phase shift, the H, the horizontal shift. All right, and so again, the numbering's all the same. All right, and we're gonna have the parent function in dash red. So let's go ahead and get started. Let's make, okay, H a positive number. And so I've kind of set it up here where it moved over, if you could tell, the blue line now, it's moved over pi force. So it's at increments of pi force. And it's unfortunately it gives it to you in decimals here, but H right now is pi force. All right, and so it's x minus pi force. Okay, and so look what it did. It moved that max over pi force. I move it over pi halves now. 1.57, right? That's half of 3.14. Okay, now look over. Now the max is over here at pi. It moved it over a half a pi. Okay, if I move it over a full pi, right? Now 3.14, right? That's a full pi. Now look, so the max was at pi halves, okay, and now it's shifted over, all right, to the right, a whole pi. So now it's at 3 pi halves. Okay, watch what happens if I shift it over 2 pi. Oh, that's crazy, right? Where'd the parent function go? If I shift it over 2 pi, it becomes the same graph. Why? Because I shifted over a whole period, right? And so it's back to where it started. Right? What happens if I move it negative? So bring it back. Let's make H 0. Okay, now if I make H negative pi halves, okay, now it moved it to the left. Okay, what's hard to tell, what's confusing is, did I move it left a half a pi, or did I move it right 3 or 1.5 pi? Right, 3 pi halves. What did I do? Well, it's the same graph either way. Okay, but you can tell right here, what did I do? I moved it, okay, to the left here a half a pi. Right, but that would be the same as if I moved it to the right, okay, 3 pi halves. You get a lot of stuff that could be written, you get the same graph that can be written a lot of different ways. Okay, so how did H affect the graph? All right, and so H affects the graph by moving the graph to the left or right. Okay. Moves the graph to the left or right. We go into more detail about how, pi halves to the left is the same as 3 pi halves to the right. Okay, if you move it over the whole period size, then it just looks like the same graph to begin with. So there's a lot of cool stuff going on here with the H. Okay. Now we have a critical connection, okay, which I think I might have already talked about here, but we'll discuss it here again. F of x equals sine of x minus h. Okay, so here the amplitude is 1. Okay, we have an h. For what values of h would we end up with the same graph as the parent sine function below? Why do we get the same graph more than once, even though the equation of the function is different? Okay, so we're going to scroll down and we're going to type in that answer there. So what did we talk about? If I move it over, okay, just a half a pi, right? And then it's not the same. Okay, how far do I have to move it over? Okay, if I want this point to end up at this point, how far do I have to move it? Okay, or another way to think of it, maybe a little bit easier. okay, is if I want to move this point all the way to this point, how far do I have to shift the graph? Or I can move it this way to the left. Okay, that distance is the same. That distance is 2 pi. So for what values of h, okay, 2 pi, 4 pi, 6 pi, negative 2 pi, okay? So any negative uh, even, okay, even coefficient times pi, all right, would work. Okay, so you could write, okay, k pi, where k is an even integer. All right, would be one way to do that. Okay, so for what values of h, okay, when h equals, I could actually write this, 2k pi, k is an element of the integers. All right, so that would work. Okay, except 0, I should say, not including 0. I mean, it was, well, if h is 0, it is the same function, but it didn't move it anywhere. All right. Sketch the graph. All right, so we have here, now it's being shifted, okay, to the left pi spots. Okay, so it's numbered the same. All right, so what points do I want to plug in? All right, well, pi happens to be a nice, easy one. I could still plug in 0, all right, because 0 plus pi is still pi, so I know sine of pi, right? But this has been shifted to the left pi spot. So instead of starting at 0, where I normally start at, I'm going to start my table of values, okay, at negative pi. All right, because that's how far I moved it. And so I still want to get a whole period in. Okay, so I'm just taking my normal 0 to 2 pi that I normally graph, and I'm moving it to the left, okay, pi spot. So it's going to start at negative pi and finish at positive pi. That's still a distance of 2 pi. All right, so when I plug in negative pi, right, I'm going to get sine of 0, which is 0. And I plug in negative pi halves, that's so sine of pi halves, which is 1. Then sine of pi, which is 0. And sine of 3 pi halves, which is negative 1. And sine of 2 pi, which is 0. So my points, I have a 0 there, a 1 there, a 0 there, negative 1 here, and a 0 there. Okay, and so you without doing the table, we know the pattern now is just going to repeat. So a 1 here, a 0 here, a negative 1 here. Oops, I went down too low. Undo, right there, and a 0 there. All right, so we'd have our sine function, okay, that has been shifted pi spots to the left, pi units to the left. That's what it looks like. Domain is all real numbers. Range is from negative 1 to 1. And all that good stuff. An infinite amount of maximums, okay, that start at negative pi and then would be good for 2 pi k after that. Okay. All right, so given the function here, all right, sine of x plus pi fourths, describe the transformation and then complete the table of values that would graph the cycle over the interval negative pi fourths to 7 pi fourths. Okay, so the transformation here is to the left pi fourths units. Okay, that's what's going on here. There's an h, okay, it's to the left. Again, it's the opposite of what you see there. So now we have to fill in the table. So again, the period is still 2 pi. right? Right now, again, we're not gonna mess with the period today at all, but the periods be the b. And we're not going to introduce the b until our next class. All right, so right now the period is always 2 pi. And so normally we start at 0, but we went to the left pi fourths. So that's why we're starting here at pi fourths. All right, so when I go to number my number line, if I were asked to graph this and I had to number my number line, right, you could still number it the way we've always done with pi halves, pi, 3 pi halves, 2 pi, right? But you're probably going to want to add a few extra numbers here, these numbers, because these are the numbers where you're going to get your max, mins, and your points to the midline. Okay, so at negative pi fourths, it's just, again, starts at sine of 0, which is 0. Okay, I still want it to count by pi halves here. All right, so negative pi fourths plus pi halves is pi fourths. Okay, and if you plug in pi fourths, you get sine of pi halves, which is 1. Okay, plug in 3 pi fourths. 3 pi fourths plus pi fourths is just pi. Sine of pi, 0. Okay, I want to add another pi halves to that, so that's going to be 5 pi fourths. Plug in 5 pi fourths. Okay, you get 6 pi fourths. Sine of 6 pi fourths, which is 3 pi halves, is negative 1. And then you plug in 7 pi fourths, okay, which adds up to 2 pi. Sine of 2 pi is 0. Okay, so you notice, right, I'm just like on the other slides, my outputs, okay, are 0, 1, 0, negative 1, 0. The only time, right, these are going to change is when my amplitude is bigger or if it's been shifted up with a k. All right, so our parent function always produces these. So left and right on the parent function should not change my y values. All right, so again, paying close attention, since I want it over this specific interval, okay, I'm going to start there, okay, and then I'm going to count by pi halves, and that's how I'm going to get my x values, because every pi halves is going to give me those critical points. Okay, and again, why do we want this interval? Because that's how it was shifted. All right, how does k affect the graph? So as always, k is going to shift the graph up and down, right? So if I make k 1, you can see how the graph went up 1 unit. Okay, it went from 0, 0 to 0, 1. It went from pi halves 1 to pi halves 2. Right? If I make k negative, okay, now it's going down 2 units, right? It went from 0, 0 to 0, negative 2. It went from pi 0 to pi negative 2. You can clearly see it's shifted down 2 units. Okay, another thing I want to point out, okay, is on the original one, the midline is here at the x-axis. I wish I could draw a straight line. Okay, there's our midline. Now that I've shifted it down 2 spots, where's my midline at now? Now my midline is at negative 2. Okay, so for sine and cosine functions, our midline will always be k. K is going to control that midline. All right, so I just wanted to point that out. So how did k affect the graph of the parent sine function? It shifts the graph up and down. All right, okay, now we're into some fun here. Create f of x so that it transforms or shifts the given parent sine function, okay, to have a midline of 3. So now I want the midline to be up here at 3. So I need to shift this graph up 3 units. So how do I get to type that in? So it's still going to be the parent function, sine of x, okay? But now I want it up 3 units. So I got to put plus 3 outside the parenthesis, okay? I put it inside the parenthesis, it's the h. That's shifting it left 3 spots. Okay, so it's taking that 0, 0 point and putting it to negative 3, 0. Right? We don't want that. We don't want left. Our midline here is still 0. Didn't do anything to the midline. To affect the midline, it's the k. And the k is outside of the parentheses. Okay, create f of x so that it shifts the given sine function, parent sine function, to have a midline of negative 2 and an amplitude of 4. All right, so let's start with the amplitude. How do I get the amplitude of 4? That's my a. So it's 4 sine x. Okay, so I've got the amplitude part down, but I just need a midline of -2. So again, that's my k, so -2. So let's double check here. Where's my midline at? My midline is at -2, I'm hoping. So how can I check that really fast? So the distance from that to the top here, okay, so from -2 to 2 is 4. And then from here to the min, okay, should also be 4. Let's check that real fast. Oops, that doesn't come with it. But so from -2 to -6, you can see that yes, that is 4. So my amplitude is still 4. All right, my midline's at -2. Okay. We want to create, again, f of x, so it transformed the given parent sine function to have an amplitude of 2 and an x-intercept at pi halves. So right now, pi halves, okay, pi halves and 3 pi halves. Right now, pi halves is a max and 3 pi halves is a min. Okay, so I'm going to have to shift this thing left and right as well as add my amplitude. So I know 2 is going to assign, an a of 2 is going to definitely give me my amplitude. So right now I have an x-intercept at 0, and I want to move it to pi halves. So I want to shift to the right pi halves. Okay, so I want to shift that to the right pi halves. So that's going to be minus pi halves. Okay, and so does it also have an x-intercept at 3 pi halves? It does. Very good. All right, so we're looking good here. Can I do this a different way? Could I do it by shifting it left? Oops. So what if I went left pi halves? Would that work? And you can see that it has an x-intercept at pi halves and an x-intercept at 3 pi halves. Okay, so now I just took those points and shifted them to the left. All right, so I could go either way there and it would still be correct. Sketch the graph, 3 sine of x minus 1, and complete the table value. So graphed already is the parent function. It says given the parent function. All right, so what is this going to do? This is going to shift this graph down 1 unit, okay, and make the amplitude 3. All right, so let's do a table of values. Okay, sine of 0 is 0, times 3 is still 0, then minus 1. Okay, so 0 is going to be at -1. Actually, let me change colors. Can I make that red? Okay. All right, and then at pi halves, okay, sine of pi halves is 1. I've got to multiply it by 3 and then subtract 1. So that's going to be 2. 3 minus 1 is 2. So at pi halves, it's 2. All right. And then at pi, it better be the same thing as 0. Should be -1. Let's double check. Sine of pi is 0. 0 times 3 is 0. 0 minus 1 is -1. Okay. At 3 pi halves, okay, what's it going to be? All right. So let me type in -1 in here. Okay. Plug in 3 pi halves. Sine of 3 pi halves is -1. Got to multiply that by 3. So 3 times -1 is -3. Minus 1 is -4. Can I count? Okay. So does that point make sense? Okay. So here's the midline. To get to the max, it's 1, 2, 3 above it. And now to get to the min, it's 1, 2, 3 below it. So that should make sense. Okay. And then it's gonna follow that pattern. Okay. All the way. All right, so again, here's the midline at -1, our K, and we go down 1, 2, 3. So we have an amplitude of 3, and we go up 1, 2, 3. We have an amplitude of 3 both directions. That's right. So what do you notice about your outputs of the table? What did I notice? Okay. The midline was shifted down one spot. Okay. You see the midline used to be 0, now it's -1. And then the max is 3 units higher than it, and the min is 3 units lower than it. Okay, that's one thing I notice. Okay, what's really happening is you're just taking the original outputs and you're multiplying them by a scale factor of 3 and then moving those down 1 unit. Now I have cosine here. So instead of doing each one individually, now I've got all these put together in one. Okay, so again, guess what A does? All right, A is going to make it larger. Okay, what's H going to do? Left and right, same as before. Okay, what's K do? Up and down, up and down. Okay, so they do the same thing. Notice the period, if I put all these back, make A1, make H0, make K0. So we're back to the parent function. Okay, what do we notice here? Okay, we notice that the period is still 2 pi. What's the difference between cosine and sine? At cosine of 0, it's 1. Right? So now the cycle here from 0 to 2 pi, the output is 1 instead of 0, but we still have those five key points. In this one, we have 2 maxes, 1 min, and 2 midlines. It still adds up to 5. 1, 2, 3, 4, 5. Okay, so each cycle shows 5 key features. Okay, so every period you should have at least 5 key. You should have exactly 5 key features. Okay, of the graph for a sine or cosine function. So it just depends on where you start the cycle at. If it's 3 midlines, maybe it's 1, 2, 3 midlines, 1 max, 1 min. It could be 2 mins. If I started at negative pi, okay, and go to pi, I have 2 mins, 1 max, and 2 midlines. But there's 5 key. And again, period's 2 pi for our parent function. So we want to cut it into 4 so we get those 5 key features put in. Okay, similarities and differences between sine and cosine. So I try to talk about a few of them. Obviously, they're both periodic functions. They both have a period of 2. All right, if you're talking about the parent function, they both have an amplitude of 1. Okay, A, H, and K affect them the same. A makes the amplitude bigger. It reflects it if it's negative. Okay, H moves it left and right, affects the phase shift, and K moves it up and down and controls the midline. Okay, the differences, okay, again, if I go back to the slide, the big difference here, if I just really fast type in sine of x, let's change the color so we know which one is which. Okay, so sine is blue. Okay, big difference is, look at the starting point, right? At 0, it's 0, 0. Okay, and for cosine, it's 0, 1, which just means the maxes are shifted. So a difference is the maxes of the sine function, okay, are a half pi to the right of the cosine ones, or you could even say 3 pi halves to the left, whichever direction you want to refer to. All right, so that's a major difference there. All right. Sketch the graph of cosine, okay, of x plus h. So that's my h. This is being cosine is being shifted to the left pi units. Okay, so I still want my table values to show one complete cycle. And since it's been shifted to the left pi, I'm going to start at negative pi. I'm going to go for it all the way to pi. All right, the period's still 2 pi, so I'm still counting by half pi here. So if I just plug these in, okay, what am I going to get? So if I plug in negative pi, now I get cosine of 0. Cosine of 0 is 1. Okay, plug in negative pi, I get cosine of pi halves. Cosine of pi halves is 0. So again, I should probably be graphing these. 1, 0. I plug in 0, I get cosine of pi. Cosine of pi is negative 1. That's down here. And you can probably guess what's going to happen, right? Plug in pi halves. Now I'm at cosine of 3 pi halves, which is 0. Plug in pi, cosine of pi. Pi plus pi is 2 pi, so cosine of 2 pi is 1. Okay, and so there you see one full cycle. Okay, that maps the whole period. Now guess what's going to happen, right? It's going to come back down and go through 0 there and end up at negative 1 here at 2 pi. Same thing here. We go through negative 3 pi there. Again, the H shift, okay, makes it move over to the left pi units. So you can see the max is normally at 0, 1, okay, but now it's to the left pi units. All right, so I want to create a sine function and a cosine function that pass through these points. Okay, so let's just start with the sine function. All right, so what do I have to do? Okay, do I want to shift it up 1 unit to get there? Then everything is going to be above. That's not good. I want to move this thing, okay, maybe to the left pi halves. What happens if I move it to the left pi halves? Am I going to hit everything? So how do I move it to the left pi halves? I want to go plus pi halves. Well, matched up. All right, now let's try cosine. We got to do a cosine one. This looks good for cosine already, though. So that was the original. What I wanted was cosine of x. Now, could I, just for the sake of it, put cosine plus 2 pi? Not equals, but plus 2 pi? And that's still the same graph. All right, what if I put 4 pi? Oh, still the same graph. What if I put minus 2 pi? Still the same graph. So again, because I'm shifting it to the left or right a whole period, it's the same graph, but don't need that. All right, now same direction, sine and cosine function that pass through the plotted points. Now look at this amplitude. So if I'm looking at the graph, it looks like my midline is right here at 1. You can see those straight dots in a row. It looks like my midline is 1, so my k is going to be 1. All right, so let's start with that fact. Go sine of x, okay, plus 1. Now my amplitude needs to be 1, 2. So my amplitude needs to be 2. All right, now it needs to be shifted pi halves to the left. So plus pi halves. And that was too far. Pi halves. Well, all right, so again, I found that the straight dots there for my midline, that's going to be my k. And I go, if the distance from that to the max is 2, so that's my amplitude. And I just wanted to find where my max was, and I wanted to move it over. I've got to do cosine. Okay, so cosine x should have the same midline, so I need a plus 1. Okay, my amplitude needs to be 2, and that should do it. I don't think I have to shift it left or right at all. There you go. I'm good to go. All right, last slide. Okay, I want to graph this one right here. Now, this is a challenge one here. Okay, the graph is not numbered. All right, so normally we want to count by pi halves, but this is being shifted to the right pi fourths. All right, so when I go to make my table of values, okay, I'm going to start at pi fourths. Period's still 2 pi, so I'm just going to add a half a pi every time. So then I want 3 pi fourths. Okay, I want 5 pi fourths. I want 7 pi fourths. And I want 9 pi fourths. And so when I go to graph, I want to make sure those numbers are there because these are the ones that are going to give me my whole numbers here. So for example, plug in pi fourths, I get cosine of 0. So we know cosine of 0 is 1. 1 times 2 is 2. 2 minus 1 is 1. Okay, so at pi fourths it's 1, but where is pi fourths at? Okay, so we normally go 0, we'll just skip 1, pi halves, pi, sorry, this is hard to write on here, pi, 3 pi halves, 2 pi, right? That's what we normally have. I don't know, that doesn't look like a 2 pi at all. Oh boy, it's hard to write with this thing. All right, so with that being said, where would pi fourths be? Pi fourths would be right here. Maybe this one's easier to write with. I want pi fourths there. Right? And then this one would be 3 pi fourths. A little bit better to write with. This line right here would be 5 pi fourths. So pretty much each little line is a pi fourths. Right? Then I got 7 pi fourths. And finally 9 pi fourths. Okay? So now I just got to go in and finish the table. So at pi fourths, I know it's 1. Okay, now sine of 3 pi fourths, so 3 pi fourths minus pi fourths is pi halves. Cosine of pi halves is 0. 0 times 2 is 0. So this one is negative 1. And I plug in 5 pi fourths. Okay, 5 pi fourths minus pi fourths is just pi. Cosine of pi is negative 1. I get negative 2. I get minus 3 right here. And this one should be another midline one, so it's going to be negative 1. And this one should be repeated back up there, so positive 1. So our graph that cycle's right there. Going too high. Okay, so our graph's going to look something like that. Oops, I didn't go down low enough. Oh, erase. Let me do that again. Erase this side. That side's messy. Okay, so we're going to go all the way. Our min is at negative 3, so I got to make sure I go down to negative 3. Okay. Back to the midpoint. So, I did a pretty bad job there, actually. I missed my points. There you go. That's better. All right. So that's what you want to do there, using the numbers that give you these nice outputs here. All right. And that's our notes.